Okay, Bismillahirrahmanirrahim. Assalamualaikum to all students. So now let's continue to the mode of operation of MOSFET. So the mode of operation are divided into three. The first one is accumulation, second one is depletion, and the third one is inversion. Okay, so now let's take a look of the name of the MOSFET. So the name is MOSFET. It is metal oxide semiconductor field effect transistor. So it will have the effect of electric field. So what is electric field? So electric field will happen when we have a positive charge at one side and we have a negative charge at the other side. So electric field will have the direction. So the direction of the electric field goes from positive to the negative. It's like a force. So when talking about MOSFET, so there is some effect of electric field. So go back to the MOS, the MOS capacitor. So we have on top is the metal, second is oxide, oxide is the insulator, and the last one is semiconductor. So inside here your semiconductor is a P type. So since here the substrate here is a P type, so the majority carrier at the substrate is hole or electron. So it's a P type, so majority carrier here is a hole. A lot of hole inside your P substrate. So what we're going to do now, we're going to apply a voltage that we call VGS. So the middle one we call the gate. So you will apply the voltage at the VGS towards your substrate. So this is what we call VGS. So let's say if we apply VGS is less than 0. What does it mean by less than 0? Means here it becomes negative, positive, negative, and positive. So now let's see. When we say have this here negative, so it will accumulate the negative charge on top of your metal. But can your metal goes down to your substrate? Of course not. Why? Because this is an insulator. So your charge of negative will maintain at on top of your metal. So when you have a negative charge, it will attract all your majority carrier from your P type. So what does that mean? Your hole will be attracted towards the surface of the oxide. So you see it's everywhere. So now your hole will be attracted towards below your oxide. So your hole is positive, right? Positive. So as we know just now, when we have a positive charge and we have a negative charge, it will create electric field towards up. Why? Because the below one is a positive charge that is being attracted due to the accumulation of negative charge on top of your metal. So there is apply an electric field at the gate. Okay. So since we know here there is a lot of let me redraw again. So this is metal, right? So there is a lot of hole here. Hole here. Can this hole move up to the metal? No, because there is insulator there. So we call this one accumulation of hole. So when you apply your VGS here, less than 0, means what will happen at the surface of the oxide here? You will have what we call accumulation of hole. Okay. So this is the notes from the slide. So when we apply a negative VGS here, we see is negative. So it will create a negative charge exist on top of your metal, and it will create electric field and attract the hole from your P-type substrate. So there will be accumulation of hole at this area. So now we will see what will happen next. Okay, so now we go to the second part. Just now is accumulation of hole happen when your VGS is less than 0. Now what will happen when you start to apply your VGS here is more than 0. So here you start to apply here plus, minus, plus, minus. Then the plus charge will be accumulated on top of your metal. So since this is a plus sign and you have a majority carrier of hole here, so it will repel all your hole towards down. So you don't have any hole attracted at the below of your oxide. So at this area there will be no carrier of hole. Why? because your electric field will move down. Means it will repel because it's the same charge, right? Due to the majority carrier of hole, it will repel all the carrier here towards down. So in this area, what we call no more carrier of hole. So we call here depletion region. So how this depletion happens? When you apply your VGS is more than 0 and your VGS is less than threshold voltage. So if we recall back, what is threshold voltage? Is the minimum voltage to turn on your MOSFET. Minimum voltage to turn on your MOSFET. So when it is not enough energy to turn on, so it become less. Let's say here is 1.5 volt. So if we apply here positive, right? But you apply only 1 volt. So still here will be depletion region, which depleted of whole carrier at this area. So this is what we call depletion. Explanation from the slide. So for the second part, so when you apply your supply here is less than is more than 0, but it is still less than the threshold voltage, so it will create an electric field towards down. You will repel all your carrier towards your down substrate. So this area what we call depletion region. Depletion region. Okay, so now let's move to the third part. So you know the first part is VGS is less than 0, it will cause accumulation of hole. And when your VGS is more than 0 but it is still less than threshold, is not enough, so you will have depletion area here. So now what will happen with the third region is when VGS is more than 0, positive, and it is also more than the threshold voltage. So here you will still apply positive voltage and you have a positive voltage here. What will happen next? It will create electric field down where all your carrier of your hole will move down. So it will create some depletion here. Since you have enough energy to turn on the MOSFET, means remember your P-type you still have what we call minority carrier. So what is the minority carrier for P-type? P-type substrate is a negative, right? So your negative will be attracted to the below of your oxide. So this area what we call electron inversion layer. Okay, so for your inversion region, so you are going to apply here VGS is more than 0 and also more than the threshold voltage. So when it is more than threshold voltage, your plus accumulated on the metal will move away all the majority carrier at your P-type. So the electric field will move down. But remember at your P-type, you have a minority carrier of the negative electron, right? So your electron will be attracted towards the surface. So this area with electron we call electron inversion layer. So just now is the inversion layer, right? So what will happen when we increase the VGS? So at first, when your VGS is less than threshold voltage, so we can call this one is either VTH. It's the same like your threshold voltage. If it's less than the turn-on voltage, you will have a no current. And if you have more than the threshold voltage, your current can flow. So what does that mean? So this is your metal, oxide, and semiconductor P-type, right? So you're going to apply what we call VGS. So what will happen when you use your VGS is less than VTH? So you will have a depletion here. So means here is plus minus, right? But it's still less than VTH. So here is plus. And we will move away your majority carrier here and we have depletion. What will happen? It is more than VTH. So it will attract your minority carrier here. So what is the role of that minority carrier? Is our aim inside your MOSFET, you want to make sure your electron can flow from what we call source and drain. So in order for this electron to move from source to drain, you need a bridge. So if there is a negative charge inversion layer happen here during this condition, so electron can move easily. So when electron can move easily, there will be current flow. So that's why at this condition, VGS is more than the threshold voltage, you will have some current. Now, what will happen when you increase more for your VGS? So let's say here is your VGS is 2 volt. So this is the area of, so let me redraw again. So this is your P type, okay? So if your VGS here is 2 volt, so your emission layer here will be only one line. You're attracted of the minority carrier. What will happen when I increase to 4 volt? So the emission layer will be double, right? Or triple. So means the bridge become larger. So this is N type, this is N type. So when the bridge become larger, it will be like a highway, right? The electron can flow easily. So you will have a lot of current. So when you increase your VGS, you will have more current. So this is the behavior, it's a resistor behavior. When you increase your voltage, your VGS, your current will be also increased. So at this part, when your VDS here is very small, your MOSFET behave like a resistor. Okay, the previous condition when your MOSFET behave like a resistor is when your VDS, there is another part here, right? VGS is at the gate, and we have another voltage that is called VDS. So this only happen when your VDS is very small. What will happen when your VDS? So where is your VDS? Is you apply your voltage from V to your substrate. So let's say you apply here very small, so it will not affect anything in the bridge, in the electron inversion layer. But what will happen when your VDS become very big? Very big. So in between here, this is a forward bias or reverse bias. So this is P type, right? This is N type. When you apply at N type, let's say this is your PN junction. So at your N type here, you apply positive, and at your P type, you apply negative plus negative. So this is reverse bias or forward bias. So this is opposite, right? So there are reverse bias happen here. But when you apply your VDS very large, the depletion region here become larger, and it will affect your inversion layer. So what does that mean? Your inversion layer will be interrupted at your drain. So now electron is not like a highway. It cannot move easily because there is some what we call here pinch off. Pinch off happen when your VDS is very large. So as we can see here, there are two parts. One, when your VDS is very small. Very small, your ID will behave like a resistor. But when your VDS is very large, it start to pinch off and it start to saturate. So if you look at this graph here, so this region is where your VDS is small. But when VDS is very large, what will happen? It will have pinch off and your current will be constant. Constant here. Okay? Okay, to sum up all the process, okay, first, at the first part, how this happen, when your VGS is less than 0, by minus, it will be accumulation. So accumulation means your aim is in your MOSFET, you want the electron to flow from your source to your drain, but now it's a positive, right? So your current will be 0 here. Next, what happened during depletion? Yes, your VGS is more than 0, but it's still less than turn on voltage. So still no current, it just depletion happens inside. And the last, second last part is where your VGS is more than 0 and also more than VTH. So it will create a bridge here. So when there is a bridge of electron, your electron can move easily from source to drain. So it will behave like a resistor. So it only happens when your VDS is very small. So we call this one active or triode region. And last part, what will happen when still your VGS is more than VTH and more than 0, but your VDS here is very large, it will be pitched off here and your current will be saturated. So that's all for the theory of the MOSFET. If you don't understand anything, please let me know. Assalamualaikum.